This is Mr. Hartz. Welcome to Day 1 Notes. Go ahead and title your notes Day 1. Today we're going to talk about limits. We're going to talk about two different forms of limits: graphical limits and function limits. These notes are going to go relatively quick since you've all had this either this summer or last year with Ms. Stevens. When we look at a graphical limit, the first thing we talk about is right-hand and left-hand limits. I'm going to copy an example of a graph, and I want you to copy this into your notes. Oftentimes with limit graphs, we have really weird, piecewise looking functions. Here's what we're going to do for today. Okay, I'll just number these 1, 2, 3, 4. Negative 1, 2, 3, 4, 5, 6. I'll go 1, 2, 3, 4, and negative 1, 2, 3, 4, 5, 6. I'm not going to label all of the hash marks on here, but they're going by ones, as you can see. First thing we want to talk about is what's called a right-hand limit. A right-hand limit is, limits are always talking about what's happening as we get closer and closer to an X number. What's happening to the Y number? What are we getting closer and closer to? Okay? Here's what the notation looks like for a right-hand limit. I'm just going to write it below the graph. My first question is, what is the limit as x approaches negative 5 plus of f of x? This function right here, we can just label the function f of x. So the question is, what happens is we approach the x value of negative 5, but this little plus down here, this plus right here, means from the right side. Doesn't mean positive 5. We're approaching negative 5 from the right side. Okay? As you see up here, if you follow my cursor, that's not working. As you approach an x value of negative 5 from the right side, we're coming along here, approaching negative 5, but we're approaching it from the right side of the graph. And ask yourself the question. I'll pause it. You can pause the video here after I ask this question. What is the limit as x goes to negative 5 plus the right-hand limit as x goes to negative 5? The answer is, the limit is 2. On the right side as I approach negative 5, we've got a limit of 2. I'm going to ask you for several others. Let's try one at not a weird place. Let's say the limit as x approaches negative 6 from the right side. Go ahead, pause the video, and ask yourself, what is the limit as x approaches negative 6 from the right side? Okay, as we see here, as we're approaching the value of negative 6, but coming from the right side, we have a y value that looks to be approximately negative 2.5. One thing that I want to note here, whether we're doing left-hand limits, right-hand limits, or just regular limits, the limit never concerns itself with what's happening at that exact x value. It's about what is it leading towards. Okay? Let's try a left-hand limit. I'm going to write this question up top here. To symbolize a left-hand limit, I'm going to approach a number from the left side. So let's ask ourselves this. What is the limit as x goes to 4 minus? Again, this is not -4. This is the limit as x goes to 4 from the left side. If I scroll up here and take a look at my graph here, now I'm approaching the x value of 4 right here, but I'm approaching it from the left side of the graph. We see we have a vertical asymptote there at x equals 4, but from the left side, what y value are we approaching as we approach 4? Pause the video and answer it. The answer is we are approaching positive infinity. Okay. Let's try another left-hand limit of one that we've already done. Let's take a look at the limit as x approaches -5 from the left-hand side. Go ahead, pause the video and answer that question. What is the limit as x approaches -5 from the left side? Okay, well, once again, now we're approaching -5, just like we did up here, but now we're approaching, that was the right-hand limit of -5. Now we want the left-hand limit of -5. As we approach -5 from the left side, we see that our y value is approximately -2. Put the answer down here, -2. Okay? What I want you to notice about the limit as x goes to -5 is that the right-hand limit and the left-hand limit were different. The right-hand limit was 2, the left-hand limit was -2. Okay? Which brings us to our first definition. Make sure you get this in your notes. The limit as x goes to a, notice there's no plus or minus after that a, just the limit as x goes to a of f of x exists if and only if the right-hand limit, again, think, what symbol am I going to use to show a right-hand limit? Well, I'm going to put a little plus after the a. The right-hand limit must equal the left-hand limit. If those two things are not the exact same number, if the right-hand limit and left-hand limit at some point, a or -5 or 3 or 2, if the left-hand and right-hand limits are different, then the limit of x as x goes to a of f of x does not exist. So let's take a look back up at our graph at this value -5 right here, this part of the graph. The right-hand limit as x goes to -5 was 2. The left-hand limit as x goes to -5 is -2. Since the left-hand limit and the right-hand limit are different, what would be the answer to this question? What is simply the limit as x goes to -5 of f of x? Take a guess, pause it. The answer is this limit does not exist. The right-hand limit and the left-hand limit were different numbers, therefore we say the limit does not exist. Let's take a look at another limit based on this graph. Okay, I'm going to scroll back up to the graph, and now we're going to be approaching the number -1. Let's again start with a right-hand limit and a left-hand limit. The first question I'm going to ask you is, what is the right-hand limit as x approaches -1? So I'll write that down here as the limit as x approaches -1 plus. This plus, again, means the right-hand limit. Okay, so again, pause, or wait till I'm on the graph, pause, and ask yourself, what is the right-hand limit as x goes to -1? The answer is the right-hand limit, as I'm approaching -1 from the right side, my y value keeps creeping closer and closer to 2. We'd say that right-hand limit equals 2. Now let's look at the left-hand limit as x approaches -1. When we approach -1 from the left-hand side, again, what y value do I keep getting closer and closer to? Take a pause and think about it. The left-hand limit, then, when I approach from the left side, our limit is also 2. Both the left and the right sides are approaching that same value. Now, you may say, well, isn't f of -1 -5 down here because it's filled in? The answer is yes, it is filled in down there, and f of -1 is -5. But the limit doesn't care what's happening at exactly x equals -1. It cares what's happening around x equals -1. Now, when we look back at our definition here, the limit exists if and only if the right-hand and left-hand limits are equal. Okay? That limit would also then equal what the value for each one of those. So when we ask ourselves the question, what is the limit? This is not a right-hand or a left-hand limit. This is just simply a limit. What is the limit as x goes to -1 of f of x? Well, for this to exist, we have to look at the right-hand limit and the left-hand limit. The right-hand limit is 2. The left-hand limit is also 2. That means the limit as x goes to -1 is 2. Now, on your AP test, when they put this in a multiple choice question, -5 will absolutely be one of the wrong answers. Okay? But that is not what the limit is. The limit is 2 because, again, the limit doesn't care what's happening down here. The limit cares what's happening around up here where these two arrows are. Okay? So the limit's all about what are we approaching as we get there. Now, how could you write a question about x equals -1 and have the answer be -5? Think about that. Well, if I wanted to write something so the answer is -5, I would simply say, what is f of -1? F of -1 does equal -5. But the limit as x goes to -1 is 2. Very important to see that. Asking more questions about this graph, what would the limit be as x approaches 4? I'll write it down here and I'll scroll back up to the graph. What's the limit as x approaches 4 of f of x? Now, anytime they ask you a limit question that's not a right-hand or a left-hand limit, we need to then check both the right and the left-hand limits to see if it even exists. If those two limits are the same, then that's your limit answer. If they're different, we don't choose one or the other. We say the limit does not exist. So take a look back at x equals 4. We already did the left-hand limit, and we got infinity. What would our right-hand limit be here at 4? Well, as we approach 4 from the right side, our y value is approaching -infinity. Since the left-hand limit is infinity and the right-hand limit is -infinity, we say that this limit does not exist. DNE is code for does not exist. Okay? Let's try one more. I'm going to draw a new graph. Okay, so here's our graph f of x. I'm going to number these -1 to -3, -4, -5. Now 1, 2 here, 3, 4, etc. Now 1, 2, 3, etc. Down here I have -1, -2, -3. Okay? After each question I ask, I want you to pause the video and try it on your own. Okay, first question. What is the limit as x goes to plus f of x? Pause. Answer. The limit as x goes to 2 from the right-hand side is talking about right down here, and that is an answer of -3. Okay, next question. What is the limit as x goes to -5? Go ahead and pause. Answer. For the limit as x goes to -5 to exist, I need to check both the right-hand and the left-hand limits. Now on this particular graph, the right-hand limit and the left-hand limit are both approaching the same number of -1. Therefore, the limit as x goes to -5 is -1. It doesn't matter that the function is undefined at -5. F of -5 is undefined, but the limit exists because the right-hand limit and the left-hand limit are the same. Okay? Next question. What is the limit as x goes to 2 of f of x? Pause. Answer. The limit as x goes to 2, again, I have to check the right-hand limit, which I already did in my first problem. That's -3. So I have to ask myself, what's the left-hand limit as x approaches 2? That would be 1. Because the right-hand limit's -3, the left-hand limit is 1. The limit as x goes to 2 does not exist. Okay, for my next question, I'm going to ask it up here. What is the limit as x goes to -3? Kind of a tough one, f of x. Pause. Okay, the limit as x goes to -3. Again, I don't see any plus or minus. I don't see a right-hand or a left-hand limit here. So they both have to agree. From the right-hand side, approaching -3, I'm going to infinity. From the left-hand side, I'm going to infinity. Therefore, the limit as x goes to -3 of f of x is infinity, positive infinity. How do we know, looking at a graph, when limits will not exist and when limits will exist? I want you to think about that. How do I know when limits will or will not exist? Think about it and pause. For me, what I look at is when I come from the right-hand side and from the left-hand side, am I approaching the same number? We can see at this -5, x equals -5, I am approaching the same number of -1. Therefore, the limit will exist there and equal -1. At -3, both of these are going up to positive infinity. Therefore, the limit will exist. However, in the previous example, you saw a vertical asymptote with one side going up to infinity and one side going down to -infinity. If we have vertical asymptotes where they split like that, the limit will not exist. But if they're both going to positive infinity or both going to -infinity, the limit will not exist. At x equals 2, we see here the limit will not exist because the right-hand limit and the left-hand limit are not equal. That's all for graphical. I will start in later with what's the word? Oh, with functions. Thank you.